13.
Continuously voice breaking, sir.
Sir,
No, it's okay.
Okay, sir. Now a little
sir,
bit better, sir.
Oh, okay. The screen is visible upper.
Ah, yes, sir. Yes, sir.
Sir.
Yes, sir.
yes, sir.
Yes, okay. So today class we are discuss about the interference in thin film by reflection method. So when the light is incident on a plane parallel thin film, that time then some portions get reflected from the upper surface and the remaining portion is transmitted into the flame. Okay, so in these cases, the same thing. Some again, the transmitted light is reflected back into the flame by the lower surface and emerges through the upper surface of the flame. So in this reflected light beams, that is act on a superimposed principle with each and every rays. That is producing the interference and forming the interference pattern. So let us consider one plate, two glass plate. This is the upper glass plate, that is the lower glass plate we have considered. So what is the thickness means? That is the T thickness we have considered. In we say that this is a particular material. Now the light should be followed on the top surface of the glass plate. Okay, so that is the A point we have considered. Okay, so in this A, the A light to fall down the B point. Okay, so in this B point, some amount of light should be reflected, some amount of light that is reflected. Okay, reflected or transmitted. So in these cases, we are only speak about only reflected and the reflected light and the transmitted light only we are speaking here. Okay, so the B point, some amount of light transmitted, that is the first ray of light. Okay, so in this ray of light will be for moving on E direction. Okay, so in this the starting of the light, the fall down the top surface of the glass plate, in this B point, some amount of light transmitted. So in this transmitted light will be fall down the back surface of the glass plate, that is the point is C. Okay, so after that in this top surface of the C point, some amount of light reflected, some amount of light again transmitted. Okay, only we are considered for two layer. So here the light should be reflected. So in this path we can say that from C to D point, then D to F, that is the light ray. So incident of the light, what is the angle occur means? That is a I. Incident of the light angle is a I. That is the transmit of the light, what is the angle means? That is we are considered for R. So already I said that that is a plane thickness. Let us consider a T thickness. Okay, so in this point, the top surface of the glass plate from BDG. So in this triangle we drawn means, so in this point also we are considered for that is the incident of the light. So in this point, this light will be fall on the top surface of the glass plate. Then the ray should be move on one particular direction, that is the F direction. Okay, so based on this particular cases, we can calculate what is the path difference. So how to
Sir, voice is not creating, sir.
only we can derive in question. Okay,
Sir,
so
voice
let us consider just one more time I will repeat what is this diagram, we can explain that. Okay, so let us consider a transparent plane parallel thin film of thick with the refractive index mu. So in this glass plate, what is the refractive index means? That is the mu refractive index. So let us monochromatic light ray, that is A to B, be incident on a angle of incident of I on the upper surface of the film, Next, BE and BC. So in this ray we say that that is a BE is a reflected ray, reflected light rays, and BC is a transmitted light rays. Let the angle of refraction is R. That is the angle of refraction is R we have considered. So in this ray, the BC will be reflected into the film and emerge through the film in the form of light ray from D to F. D to F. That is, we say that light ray 2. Okay, so these two light rays that is acting on a superimpose and depending upon the path difference. So in this light ray 1 and the light ray 2, what is the path difference? Based on this path difference between them, they producing interference pattern. They produce the interference pattern. Okay, so now we can calculate what is the path difference in this DG. So in this angle and BE in this angle, this ray 1 and this particular point, what is the path difference? So from the point the B and the G onwards, the light rays that is equal to the distance. By the time the light ray travels from B to G, the transmit light rays as travel from B to C and C to D. Okay, now we can calculate. So what I'm saying, the same points only we can given that your words here. Okay, so we can write it. What is the path difference between the light rays? The light rays 1 and 2. You can write it. What is the path difference means? That is mu. Mu is a refractive index of the film into BC plus CD in film. Just to see that diagram. Okay, you can write it the path difference equations. This is the inside of the film. This is the outside of the film. That is the upper surface. Okay, so here what is the medium means? That is the air medium. Here what is the medium means? That is a thin film medium. Okay, so we can calculate what is the path difference of this two ray means. So first of all, I will write it inside of the film. What is the path difference? So inside of the film, depending upon the materials. So what is the refractive index of that particular medium? So refractive index mu into BC plus CD. BC plus CD. That is the inside of the film. Okay, next minus. What is the outside of the film? That is a ray, light ray 1. We see that BG. So in this BG, where is the occur means that is the air medium occur. So that is, we can write it the equation number 1. That is a path difference equal mu into BC plus CD in film minus BG in air portion. So that is the equation number 1 we have considered. Now we can calculate what is the BC values, what is the CD values, what is the BG values. Now we can.
Excuse me, sir. Sir.
So, yeah.
Sir, once again explain, sir. Path difference, sir.
Yeah. You see that? So this is a we can calculate what is the path difference here. So how to calculate path difference from the light rays 1 and 2? Okay. So just to go to diagrams. So this is a diagrams. Yeah. So in this diagram, this is a light ray 1. This is a light ray 2. Okay. So first of all, the inside of the film minus outside of the film, you can subtract this. That is a path ray path difference of this. So in this film, we can calculate. How to calculate means, first of all, the path difference, that is equal to inside of the film, you can write it. So inside of the film, you can write it means, first of all, what is the need means, that particular material, what is the refractive index? Because of based on the refractive index, the light should be travel, the direction should be different. Okay, so first of all, you can multiply refractive index of that particular medium. Okay, so mu you can multiply. So mu into, from this is a transmitter light. Yeah, so inside of the film, this light ray will be followed on the C point, then the C point will be reflected again, go to the light ray 2. Okay, so in this path, we can add it. That is a BC plus CD. So refractive index mu into, you can multiply mu into this value, BC into CD. Okay, so inside of the film. So in film minus, because you can subtract the air medium. So air medium means the B point should be reflected light ray 1. So in this point you subtracted means that is a path difference of this plane. Okay. So the outside of the point, that is from B to G. So this value where is occur means that is a air medium occur that equation. Okay. So that only we can write it here. Path difference mu into BC plus CD in film minus BG in air medium. Okay.
Okay,
You
sir.
got
Okay, sir.
it?
Thank you, sir.
Okay. So in this is a equation number 1 I have considered. Now I will calculate what is the BC value, what is the CD value, what is the BG value. So these three values I will calculate first of all. Then that value should be apply here in this formula means we can get it the path difference. Okay, so the BC value, how to get it means just you see that the again diagram. So BC, so this point we want. So in this point you can we can consider this is means BCD. So we cannot finding that what is the value of this BC. Okay, so I will perpendicular line draw that from C to H. So in this region, what is the angle means? That is we see that R angle. This both the angles should be equal because of the perpendicular line draw that one straight line. That is the C point. So now we see that BCH, one is a triangle. Next HCD, that is another triangle. Okay, so now in this triangle, you can find just use R. What is from H to C? This is the upper surface of the plane. That is the down surface of the plane. What is the thickness? That is the T thickness we have considered. So now we can calculate what is the value you can calculate, BC value you can calculate. So how to calculate BC values? So in this angle, in this distance I want. So how to calculate these values? With the help of trigonometric formula. Okay, so already you know that the trigonometric formula, that is the sine theta. What is the sine theta? Opposite divided by hypotenuse, that is the sine theta. Cos theta means adjacent divided by hypotenuse. Tan theta means that is the sine by cos. Yeah, that is the opposite by adjacent. So that is the trigonometric formula. So now we see that this is the angle. You consider theta. Now we can consider theta here. Okay. So theta here means the opposite side. This is the opposite. BH is the opposite side. Next, adjacent side, HC is the adjacent side. Hypotenuse side, BC point. So in this triangle, this is the opposite, adjacent, and the hypotenuse. So now, which value you can want? What are the values? You know that the adjacent side values, I know that. BH values, we don't know. Next, hypotenuse value only we can determine. So which trigonometric formula we can opt? For the example, let us consider sine theta. So sine theta means what? Opposite divided by adjacent. What is the opposite? BH divided by BC. BH divided by BC. So BH values, you know that we don't know. So we cannot find that what is the BC value. So sine theta, it's not suitable to using this here. So next we go for cos theta. So cos theta means adjacent divided by hypotenuse. Adjacent side means HC divided by hypotenuse means BC. So HC values, you know that is a T values. So one side value you know means other side values we can easily determine. So let us consider cos theta, that is a suitable for trigonometric formula. So cos, what is the angle here considered means that's the reflector light ray. Yeah, that is the R angles we have considered. So R, you put it here. So that is a cos R equal adjacent divided by hypotenuse. Adjacent divided by hypotenuse. Okay. So in these cases, so cos R equal to adjacent divided by hypotenuse. Okay. So adjacent side, what is the adjacent side? That is a HC. So you can write it cos R equal to HC divided by the hypotenuse side, that is a BC. So HC divided by BC. Okay. So now I want only for BC values. So BC values move on left hand side. The cos R, that is a move on right hand side. So BC here, division term move on left hand side means that is a multiplication. So BC equal to HC divided by cos R. What is the cos R? Cos R equal to, that is a, yeah, HC equal to, that is a t values. This cos R is the multiplication term, move on right hand side means that is the division. Okay, so BC equal to t divided by cos R. So this value you can find. Okay, next, the same way, that is a similar way we can find that in this angle, that is that is we can determine CD values. Yeah, so CD values means you can take it the right hand side triangle, that is a HCD. HCD, this triangle. So in this triangle I draw it here, HCD. Okay, so in this triangle, what is the value? You know that HC side values, you know that HD value we don't know, DC value or CD value we don't know. So now we can calculate what is the CD value. So that is a similarly we are taking the triangle DCH triangle we are taking. Okay, now we can calculate what is the DC value. So DC value, how to calculate? With the help of trigonometric formula, okay, we can determine that DC value. Okay, so the same thing, sin theta, cos theta, tan theta. So which formula we can out means the sin theta means that is a adjacent divided by hypotenuse. So adjacent means HT value. So HT value we don't know, so we cannot use it that sin trigonometric formula. Then you go for cos formula. So cos theta equal to adjacent divided by hypotenuse.
Hypotenuse.
Yeah, yeah, hypotenuse. Adjacent side is a HC. So HC divided by hypotenuse DC. Okay, the HC value you know that is a thickness T. Okay, so cos R equal to HC T divided by DC. So I want only DC value or CD value. The symbol should be rewrite. Okay, DC. The CD values, DC can move on left hand side, this cos R move on right hand side means, so that is move on left hand side multiplication. So DC equal to T divided by cos R, T divided by cos R. So this is a CD value or DC values. Okay, so we see that the path difference equation mu equal to BC plus CD value in Philip. So we can determine in this BC value and the CD value or DC value. In this value we can determine now. Yeah, you already find the values are got it. Then you go to find that now BG values. How to calculate BG values? With the help of this triangle, we see that BG values, these values we can determine. So this value you can determine means I will draw the one perpendicular line here from D point. So this, now we consider that BDG. So this is one of the triangle. So in this triangle, we can determine in this BG value means any one side value you know that first of all. So first of all you see that which side values you know that BD values, this particular side we don't know what is the distance. Otherwise D to G, what is the distance we don't know. Okay, so any one side distance. So you see that this is a BDG, this is the angle of I. So in this triangle side, so this value you can calculate very difficult. This side also, this side only we can find, that is our target. But this side we can find means very difficult. So only possibilities, what is the BD values? How to calculate these BD values? With the help of this true triangle, we can calculate first of all BH value and the HD values. Both the value we added means that is the BD values. So now we can calculate the BD values here. Okay, so to calculate BG, first the BD with BH see the same triangle, the inside of the film triangle only we have considered. So here that is opposite, adjacent, hypotenuse. Okay, so in this triangle, in this triangle we can calculate what is the BH values. Okay, so we can calculate what is the BH value. So in this now we can say that theta opposite divided by hypotenuse. So hypotenuse value is also we don't know. So that is not possible because of I want only this value. So this value means we can use it only for sin theta formula, but that is also not possible. Okay. So next to go for cos. Cos means only we can determine again BC value only. So that is a no need in our cases. Next to go for tan theta. So tan theta is a opposite divided by adjacent side. So what is the opposite side? That is a BH divided by HC. BH divided by HC. So that is a tan R equal to BH divided by HC. Tan R equal to BH divided by HC. Okay, so in this equation, I want only what is the BH value only I want. Okay, so BH, I will kept it right hand side. Remaining term move on opposite side. So this is a division term. Move on left hand side means that is a multiplication. So HC, what is the HC value? That is a T. So T into tan R, BH equal to T into tan R. So this BH value we are determined. Okay. So next to go for next another triangle. Just you see that in this diagram. BH value you find that. Next you can find what is the HD value. So in this HD value we can calculate again the similar way only we can calculate. The similarly that is you can write it tan R equal to HD by HC, that is opposite. Here one triangle means this is a D point, this is a D point. So HD values we can determine. So tan R equal to HD divided by HC. So in these equations, I want only HD values. So HD equal to HC value. What is the HC? That is the distance. Distance is T. So T into tan R HD value. So I want for total distance in this plane. Yeah. You see that the total film from B to D, what is the distance? So BH value plus HD value added means you can get it the total distance of that position. Okay, so the BD value. So just to see that in this equation, so BD equal to BH plus HT. So BH value you know that. So what is the BH value? T into tan R. T into tan R plus HD value. HD value means that is the T into tan R. T into tan R. So T plus T, both the terms same. Yeah, 2T tan R you can write it. That is the BD value. Okay, so the BD value you know that. So in these values you know that. Now we can calculate what is the BG value. So now we can take it for this triangle from BGD. Sorry, BDG triangle you can take it. So this is the angle of incident line. So now we can calculate BG. So BG value means again using the trigonometric formula. Which formula we can opt here. So next, so this is the angle means this is the opposite, that is the adjacent, that is the hypotenuse. So sin theta means opposite divided by hypotenuse. So opposite means that is a BG value. So BG value only we can determine now. So that is a sin is a opt. So sin I equal to BG divided by BD. So that is the opposite divided by hypotenuse side. Okay. So I want only for BG values. So this BD division term move on right hand side means that is a multiplication. So BD into sin I, that is equal to BG. So BG equal to BD. What is the BD value? Already we can determine that BD values. That is a 2D into tan R. So this value substitute here. So 2T into tan R into sin I. So that is the equation. Yeah, sin I. That is the equation number 2. From the Snell's law, you studied that Snell's law. What is the Snell's law? The ratio of the sine of the angles of incident and transmission is equal to the ratio of the refractive index of the materials at the interface. That is called the Snell's law. So what is the conditions? The Snell's law, that is a sin I equal to mu into sin R. That is the incident light that is equal to what is the reflector of the light, that is the Snell's law. Based on this Snell's law, you can write it in these equations. Okay, so the Bg equal to 2d tan r, the sin a can be replaced to mu into sin r. So this value substitute in equation number 2, that is we can write it equation number 2, substitute sin a values. So Bg equal to 2 mu t tan r into sin r. Yeah, you got it. This one sin a can be replaced to mu into sin r. So this value substitute here. So this is the equation number 3. Okay, so in this equation number, Bg values, Bc values, and Cd values, both the values you know that because of what is our target, we can determine what is the path difference of this thin film. Okay, so path difference only our target. So the path difference equation, that is equation number 1, you know that mu into Bc plus Cd in film minus Bg in F. So all the values you know that, substitute all the values in this equation number 1. Okay, so that is I can write it here. Equation number 1, substitute in the equation number 1. The path difference mu into Bc. So Bc value you know that t plus t divided by cos r. T divided by cos r. Next Cd value you know that t divided by cos r minus Bg value. Bg value, what is the value? 2 mu t tan r into sin r. 2 mu t tan r into sin r. Okay, so in this equation t by cos r plus t by cos r, base same, power should be added. Yeah, so 2t cos r, 2t cos r. So this mu value multiply inside means 2 mu t divided by cos r, 2 mu t divided by cos r. Okay, so first term minus the right second term 2 mu t tan r into sin r, tan r into sin r. Okay, so now we see that now we can simplify this equation. So the first term 2 mu t divided by cos r minus 2 mu t can be replaced to this formula. So 2 mu t sin r divided by cos r into sin r. Okay, so the sin into sin, that is a sin square of 2 mu t divided by cos r minus 2 mu t sin square r divided by cos r. So now we see that here also cos r, here also cos r. So commonly you can write it cos r means the top side 2 mu t minus 2 mu t sin square r. So both the term 2 mu t cos r common, yeah, so take it common outside. So common outside means 1 minus sin square or 1 minus sin square r. So 2 mu t cos r. So already you know that the sin theta plus cos square theta equal to 1. So I want only a cos square theta to write 1 minus sin square theta. So here 1 minus sin square r, here 1 minus sin square theta. So that is you can replace to cos theta. That is a cos square r. So 2 mu t divided by cos r into cos square r, you can write it. Okay, so this cos r, this square cancel. Then you can get it 2 mu t into cos r. That is the path difference of this equation. So this is the equation number 4. You can write it. Now you can add it. What is the phase difference of constructive interference and the destructive interference? So that is also we can determine in this equation because that is a very important thing. So in this the point B, reflection occur from the upper surface of the medium. So that medium we say that denser medium of the ray. So in this denser medium, what is the light ray undergoes an additional phase change of phi or additional path difference of lambda by 2. So yesterday classes I said that what is the path difference of constructive interference and the destructive interference. So addition of this lambda by 2 added in this path difference means that is a denser medium. So let's say that another one, that is a ray 2, that is we say that rarer medium, that is a C point. So inside of the plane, in this point. So see that, so in this point we say that denser medium, this point we say that that is a rarer medium of the plane. Okay, so you can write it the denser medium of the path difference, additional path difference, you can add it. So now we can write it what is the total path difference, that is the 2 mu t cos r, that is the path difference 2 mu t cos r, plus additionally you can add it, means that is a lambda by 2 light ray 1, that is the denser medium cases, so plus lambda by 2. When the path difference is equal to integral multiple of lambda, then the raise 1 and the raise 2 meet in the phase, that is undergo the consecutive interference. Now we can write it what is the conditions of bright fringe. The consecutive interference means that is a bright fringe, I said that, yeah. So we can write it what is the conditions in the bright fringe cases. So you know that the total path difference, the 2 mu t cos r plus lambda by 2, 2 mu t cos r plus lambda by 2, that is equal to, in the condition of bright fringes, n lambda. So I want what is the this path difference only, this values, the path difference values only we can determine. Okay, so the path difference only I will kept it left hand side. This additionally added the phase difference, that is move on opposite side. So 2 mu t cos r equal to n lambda minus lambda by 2. Okay, so this is a division term, cross multiply, you can multiply. So 2n lambda minus lambda by 2. Okay, so here you can write it, you see that here also lambda, here also lambda, 2 is the common, you take it common outside, so 2n lambda by 2, lambda by 2 take it outside means minus 1, 2n minus 1 into lambda by 2, that is equal to 2 mu t cos r, that is a path difference. So here what is the n means, that is the integers value starting from 0 to 1 2 3 we have considered. So this is the conditions for bright fringes. So now we can write it what is the conditions of dark fringes. Okay, so in these conditions, in the dark fringes, that is you can say that the statement, the path difference is equal to the op integral multiples of lambda, then the raise 1 and 2 meet in the out of phase and undergo the destructive interference of the fringes. So the conditions for dark fringes is, you know the conditions, 2 mu t cos r plus lambda by 2, that is the total path difference, that is equal to, what is the condition means, 2n plus 1 into lambda by 2. Okay, so in these equations, only I will write it what is the path difference, 2 mu t cos r, that is only I will write it left hand side, remaining lambda by 2 move on right hand side means, that is the plus term, move on right hand side means minus. So 2n plus 1 into lambda by 2 minus lambda by 2. Okay, so now we can see that in this equation we can simplify that. Here also lambda by 2 multiply inside, so 2n lambda by 2 plus 1 into lambda by 2, lambda by 2 minus minus lambda by 2. Okay, so this plus and the minus you cancel it, then what is the remaining value, 2n lambda by 2, 2 cancel, so n lambda, so 2 mu t cos r equal to n lambda. So this is the conditions for dark fringes. So these two conditions are very very important. So the interference of the thin film by reflection method, what is the bright fringe conditions. What is the condition of dark fringe